So now we're going to take what we just talked about in terms of the basic statistics, mean and average, normal distribution, and outliers. And we're going to apply it now to repair orders. And in particular, comparing it against something called the dwell efficiency ratio. And the dwell efficiency ratio is simply a comparison of our dwell time compared against our sold time. So if we have 10 hours of dwell time and we have 1 hour of sold, our dwell efficiency ratio is 10. The lower this gets, the better we are at turning work. So we're going to draw a simple graph again, a simple chart. On this side will be simply repair order count. And on this side down here will be our dwell efficiency ratio. And for the sake of ease, we're just going to break this into groups of 100. And down on this graph, we're going to break it just in by ones. And so we're going to make an assumption that we sample 1,000 repair orders. It's a random sample of 1,000 repair orders. And we're going to get a mean for this dwell efficiency ratio. And again, we're just going to make the assumption that our mean is 4. So in other words, we have 4 hours for every 1 hour of sold time, 4 dwell hours for every 1 hour of sold time. And our graph ends up looking something like this. And if you remember back to a conversation that we had earlier, we have something called standard deviation. In this case, we don't worry about the second standard deviation, which is 95% of the data is contained within the standard deviation from the mean. So we have our first one. Here's our second one. And so 95% of our data, of our repair orders, the repair order count, is falling inside of that distribution. And if we apply the thought of outliers, then we're going to look at the repair orders that make up these two tails. And we're going to try and learn some things from them. First of all, on this side, where the dwell efficiency ratio is high, okay, remember that's bad for the dwell efficiency ratio to be high. We're going to look at those repair orders and see what is happening to those repair orders. And let's just make the assumption that that's 25 repair orders. And so we might learn things like that there's one customer in there that we have trouble getting repair or purchase orders for. We have trouble doing certain types of repairs. We've got a technician that is always slow and it's always putting his or her work out in this tail end. Some of these things we may be able to fix, some of them we may never be able to fix. But what we want to learn is what is happening on those outliers. How do we fix them? And how do we apply what we learned into the remainder of this distribution? On the other side of it, we learn what's good. We have our dwell efficiency ratio of 2 or less. We have our 25 repair orders, for example, and we start to learn from those 25. All of these repair orders, for example, might go through triage, express, assess. They may go into our quick service bay very, very quickly. We may have pre-pulled all the parts for them. We may have a service advisor that is exceptionally good that is in these repair orders. What can we learn from these repair orders and start to apply it to the remainder of the repair orders? By doing so over time and working with those outliers, what we'll start to see is the mean may never change, although it probably will, but we're going to make the assumption that it doesn't. But as we work on the outliers, the graph will start to shift, and it's going to look something like that. We then still have our same standard deviations, 1, now 2, we have 95%, but now that 95% is in this area. And so now we're sampling the outliers down in these tails. You'll see that it's tightened up. Our work has become more predictable. The customer experience is better. And over time, we're going to affect this dwell efficiency ratio by learning from it and starting to move the mean to the left.